Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Medium Destruction by NXT Master. And here are the rules. We have standard irregular 6x6 Sudoku rules apply, except the give. Okay. So what is standard 6x6 irregular rule Sudoku? That means in every cell in the grid, we need to place a digit such that every row, column, and designated 6-cell region must contain the digits 1 through 6 exactly once each. Now, here is the exception to this rule. Except that the given regions are false and must be destroyed by making sure none contain all digits 1 through 6. Additionally, the real regions... Okay, so how would I put this? So this is not... Okay. So in every cell in the grid, place a single digit from 1 through 6. Place a single digit such that every row, column, and undisclosed real region, 6-cell real region, must contain the digits 1 through 6 exactly once each. So, the designated 6-cell regions cannot contain the digits 1 through 6 exactly once each. And the real regions that are created must be orthogonally connected. That's the way I would put it, I guess. And so, for example, what does orthogonally connected means? It means that you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So, for example, to get from here to here, you have to go this way, but it's all staying within the region, all going through edges. This is not a valid orthogonally connected region because you either have to go through a corner or you have to go through another region to get to any other cell in the region. So that's how I would put this rule set. Additionally, the real regions must be deduced such that the digits in a circle represent how many of its surrounding 8 cells and itself belong to the real and false regions the circle is in. Circles basically count overlap. The way I would put this is the digits that... So the digit in a circle indicates how many of the 9 cells in 3x3 centered on the circle are both in the real region and the false region that the circle is in. So this is the false region. So as an example, say we had the example I used for this was the real region. In this example, this is the false region, this is the real region, and in the 3x3 box that's centered around the circle, there's only 2 cells which are in both the real region and the false region, these 2 cells. So in this case, the circle here would have to contain a 2. And that's an example of how the circles work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Interesting. So... Huh. This is interesting. Okay, so let's look at the circles. The circles can never be 6 for one thing, right? Because if you have 6 that are in the same region, that means the region is valid. So that's not possible. This has 3 cells in the 3x3 region. Um, hmm. This can have up to 1, 2, 3, 4, 5. So this could be 1 through 5. This could only have 1, 2, and 3 in both the real and false regions, these 3 cells, but it can't be, it could be 3. This can have 1, 2, 3, 4, 5, but it can't have 1 or 3. So this is 2, 4, or 5 here. This can have 1, 2, 3, 4, and no 1. So this is 2, 3, or 4. This could have up to 3 also, right? So in that case, it would be 1, 2, or 3 here. This would have up to 3 in this 3x3 box, but it can't be 2, so it's 1 or 3, and this has up to 3. So this is 1 or 3. Okay, that's interesting. So this is a 1, 3, 1, 3 as a pair. The remaining digits in row 6 are 4, 5, and 6. And this cell, either one of these cells is 1. It cannot be this one. If it's just 1 here, the problem is they can't extend as a region at all, because none of these can be part of its real region. And then this is stuck. So this must be 3, which makes this 1. So all 3 of these are in the same region as itself. And then this one is 1. So it has to go this way. Because it can't include this, it can't include that. So we have a boundary here, a boundary here. And this must go this way. I'm going to mark that as yellow. Wait, this is only 2 at most. And it's either 1 or 2. Okay, so I missed a boundary there. Apologies. So this is just 2. So this has to be 2. This is part of the same region. It could be part of red, and in fact, I think it is part of red, but we'll see. This has to be 4 or 5. Remaining digits in column 3 and column 6 are 3, 4, 5, 6. Okay. And that's 7. 3, 4, 5, 6. This can't be 3. This can't be 6. Okay. So this can never be 3. If it's 3, that means these are all in the same region, and this would be 2 3s in the same region. In the same real region. So that can't be 3. This cannot be 3 or 6. We have 1, 2, 4, 5 there. This is 3. Let's see. If this was 5, that means all of these would be the same region, and this would not. Because if you try to have all of these in the same region, it's the same as the false region, which is obviously not going to work. If you have 4 here, what does that mean? So if this is 5, that means all of these are the same. And that satisfies that. Because this would have 3 that are the same here, and that's valid. If this is 3, that's interesting. Then this cannot be 3. This would have to be 4. So these would have to be connected. And it would have to be something like that. But that doesn't work. So say this was 3. That means all 3 of these are the same region. This would have to be 4 as the same region. So you would have to have these connected, and it would have to connect this way because it can't connect through that, because this would be 3 and that would be 3. But then the yellow region can't be part of that region. It would have to go all the way around here, and that's not possible. So this cannot be 3 either. So we have a 1, 2, 1, 2 pair in column 5. That leaves the remaining digits as 3 through 6. This can't be 3. This can't be 3. This can't be 3. Oh, this can't be 6 here. Interesting. Now we have a 4, 5, 6 triplet in row 3, which eliminates 4, 5, 6 in the rest of the row. So this is 1, 2, and 1, 2. Right, so if we have 3 that has to connect, then these would be in the same region, and they would have 2 3s in the real region. If this were 3, these would have to connect, then 3 could not be in the same region as this, so then this would have to be 4 connecting as the real region there. So it has to connect that way. The yellow would have to go through here, and you'd have 2 1s in the real region for yellow, which is not allowed. That's why it's 1, 2, 1, 2. Oh, that's interesting. If this is 1, it cannot go this way. It has to, well, you don't know how. So this would be 1 or 2. If this is 2, if this is, this can't be 5 now. Because if this is 5, all of these are the same region, but then this can't be 2, because these would be the same real region here. And like, this can't be 3. So this is 4 then. This is 4, which eliminates 4 in the row and 4 in the column. So this is 3, 5, 6. This cannot be 3, 5, or 3 or 6. So this is 5, which eliminates 5 here and eliminates 5 here. The remaining digits in column 4 have to be 1, 2, 5, 6. This can't be 6, obviously. 1, 2, 5, 6. If this was 4 and didn't include the 3, the problem is that then this would have to be 4 this way. The 3 could not have 3 of the digits in the surrounding 3 by 3 box be part of its region then. So this has to be in the same region. So we're going to mark that as pink. It could be part of yellow, actually. So these two are part of the same region. So we have 1 out of 1 of these 2 is the same region. If we have these 2, I guess it's possible. If this is 1, and it's part of, it can't be part of the pink region. This would have to be 2 and part of that region, so it would be those 2 then. So if this is 1, this is not part of the pink region. If it's 2, it's not part of the pink region. Or it could be, I guess. It would be that? Okay. Interesting. Whichever region this 2 is in, it's going to have a 1 that goes with it. Right? Even if we try to exit out this way. I guess it might not have to. Hmm. This can't be 5. So the remaining digits in column 1 are 1, 2, and 4. We have a 1, 2, 1, 2 pair in the 3, 4 here. Obviously, this cannot be 5 and 6. um, hmm. Hmm. Can this be 5? Yes, it's still valid to be 5. Hmm. Huh. Can it be neither of these? I think the answer can it be like these 4? And I think the answer to that is no. Because if we had 4 of these in the same region, that means this is not the same region. This is not the same region because this can only have 4 that are in the real region and the false region. And then this couldn't be the same region because if it were, then this would have to be 3. And we have a repeat in that region. So it cannot be the full 4 here. Obviously, oh. And if that's the case, so if this is 1, obviously these aren't the same region. Then this would have to be 4 this way, but then this would have to be 2. And that couldn't be part of this region, because that would have to actually be 3 to fulfill the circle and still be part of this region. So this can't be 1, this has to be 2. So this is 2, this is 1, which means these are different regions. This is 2, so these are different regions. It could just be these 2, right? Oh, it's not true. If this is 2 this way, the problem is this can't be an actual 4. Because none of these 2 are the same region, that's 3 at most then. So these must be the same region also. So these are the same region, these 2 are the 2 valid here, this must be the same there, this is not the same region. So this is done, that's a border that way. To connect, okay, so this is a border because you can't have 2 in the same real region. You have to connect this way. So then it must connect this way then. 2 is a separate region here. It probably is part of yellow. This can't be 2, and this can't be 2. Red needs access to a 2. So it either has to go that way or to here. And that's still fine. So this is all the same region. This can't be 4. This can't be 3, because if we try to connect this some other way without this, it doesn't work, because then this is not part of a region. So then this is 6, this is 5, which eliminates 5 and 6 in the rest of the column. This can't be 5 or 6, it's 4. This can't be 4, 5, or 6, it's 3. 6 eliminates 6 here, so that's 3. This can't be 5. This can't be 5. We need access to a 1, and this can't be 1 anymore because of the 1 in the row. This can't be 1 here. Where does the pink have access to the 1? It's only here. So, we're gonna make this, it can't have access to this one because then this would fail. And then this also would fail. Because this only has 1 that's in the same real and false region, which would be itself. This has 3, which is already accounted for. This has 4, which is already accounted for. This is 2. 1 can't be reached here, here, cannot go through there, can't be reached here, can't be reached here, because this already has all 4 of its real and false cells in the same region. This has already 2. So then it has to access that. So we're going to make this actually blue. And that's done as a region. So this is done as a region. This yellow has to continue here because there's no other way. So this is all yellow. And it must go to here. And then that's done as a region. This yellow cannot have more than 1, so this is a 5, 6 pair, which eliminates 5 and 6 in the rest of the region. So this must be 3. That eliminates 3 from being here and here. Red could still be here. Okay, so red cannot continue through here, but it could go through here. This 4 eliminates 4 here. This 3 eliminates 3 here. This can't be 3 because 3 in the column. We have a 2, 4, 5 triplet in row 2, which eliminates 2, 4, 5 in the rest of the column. Sorry, rest of the row, so this is 3. That gives us all the 3s then. We're going to make this the green 3, the pink 3, and the orange 3 here. This can't be 3 because of the 3 in the row. The remaining digits are 1, 4, 5, 6. This is 1, 2, 4, 5, 6. Okay, this is 5, 6 as a pair. This is either orange or pink here. This could be red, green, or pink here. It's blocked from being part of orange, so red, green, or pink. If green goes here, that means red has to go through this way. That's possible. Okay. If this were 5, how many did... Okay, so this would then have to be one region by itself, and then this would have to be part of this, essentially. Because this would be a full, whatever, 5 regions. This would then have to be 4, 5, 6. This would be 2 and 1. Seems fine. 5 would be here. 3... 5, 3, 2, 1, 4. That seems fine. What about 2 and 4 here? The only way this is 5, then, is if this is 2, right? Oh, this can't be 5 because of the 5, 6 pair in the column. So this is 2 and 1. So we know for certain this is 2 and 1, which eliminates 2 here and 1 here. So it's at least 4. Interesting. So if it is the full 5, it has to be that, and then this. Oh, that doesn't work. Okay. So it can't be the full 5. If it's the full 5, this is too many digits here. That would be 1, 2, 3, 4, 5, 6, 7, 8 remaining digits, and only 1 could be taken up from the 5, and that wouldn't work. So this is 4, which makes this 5. Therefore, this can't be 5 here. This 4 eliminates 4 in the rest of the column. This 1 cannot be part of that 1, but it could be pink. Okay, so if we try to go pink, how does that work? If this is part of pink, this would have to be the full 4, but then orange wouldn't have a region, right? You have to have 6 here, and then this would be 3 cells. So this cannot be part of pink, it must be part of orange. This must be part of pink because it can't really be part of green. If it's green, then this is essentially pink, pink, and then it's stuck. That's 5 cells. So this must be part of pink then. That means orange has to be all of these. So this is orange, and it's done as a region. Pink has to connect this way, so this is pink. We have 1, 2. It could be 3, 4, 5, 6. In fact, it probably is, or something like that. Okay, so yeah, this cannot be separate from the pink region. If it is, then this is only 3 cells in a region, which is not allowed. So this must be part of pink. So we have 1, 2, 3, 4, and then it has 2 out of these 3 cells be part of its region. So this is a border. This can't be 4 because of the pink cells. So pink can be, this can't be pink anymore. It's either green or it's red. Red cannot go any further up than here. And this can't be pink because that would be 1, 2, 3, 4, 5, 6, but this would not satisfy 4 cells in the same real and false region. So then this must be green. And if this is green, the green has to be able to connect this way. So this cannot be part of green. We already have 4. We must connect. That's 5. And then this is 6. So this is red. And to connect to red, it has to connect that way. And this is 1, 2, 3, 4, 5, 6 as a region. So that's done. Okay, we have green. This cannot be anything but green. And so this is green. So this has to be pink. Because if we try to have green, green here, that's 1, 2, 3, 4, 5, 6, 7 cells in the region. And because this is pink, it cannot be 4. So this is not 4. This is 6. This can't be 6. That's 5. Therefore, this is 4 here, which makes that a 1. This can't be 1 here. This 1 eliminates 1 here, so this is 2. This is 4. 6 eliminates 6 here, so it's 4 and 6. That forces this to be 2 and this to be 1 here. We have 1, 2, 3, 4, 5, 6 here. So this can't be part of green, it's part of pink. And this must be part of green. So then we have all the regions. We need to see now the fake regions not have the digits 1 through 6. This can't be 1. This is 1, 2, 3, 4, 5 here, so this can't be 6. So this is 5, that's 6, this is 5, and that's 6. And that's the solution. Yeah, this is very interesting, actually. I did one of these destruction puzzles before, and that was a how to learn how to Sudoku. So, this has some interesting implications here, though. I'll get to that sometime later. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.